All right, today we're going to be talking about stacks and queues. Stacks and queues. The lesson is going to have three separate parts. It's going to have the part, why do we care? Why do we care about a stack or a queue? What does it have to do with computer programming at all? The next part will be the what. What is a stack and a queue more specifically? We'll go over a little bit of it here in a broader picture sense, but this part will look a little bit deeper into what is a stack and what is a queue. Finally, we'll look at the how. How do we implement a very simple stack and queue so you can see exactly what goes on? Now, because this is a pre-recorded lecture, I can't quite interact with you like I would normally interact. So I'll leave some brief pauses for you to think about different areas that I'm going through, and hopefully they'll take the place of asking questions during that time. But if you have any questions about this lecture afterwards, please feel free to contact me and ask me those questions. Okay, so we're going into the idea of stacks and queues. Why is it important? Why is a stack and a queue important? Well, stacks and queues represent data structure. They're both a type of data structure. Data structures are a fundamental aspect of programming in the sense that ultimately we're trying to do stuff with data. We're trying to take stuff and put it in structures that make sense and remove it from structures that make sense. We could think of a data structure, we could say, well, let's just have a one-size-fits-all data structure. Kind of like when you wake up for breakfast, why not just have everything available? Eggs, waffles, ham, cereal, whatever you could possibly want, let's have that ready for breakfast. You can see that would be a little inefficient. Can you imagine waking up every morning and thinking to yourself, wow, I have to make the eggs, make the ham, get the cereal, milk, all that stuff, when you really just want waffles? Why would you go through all that effort when you just really want waffles? It's the same thing with data structures, same thing with programming. If you know what you want, the structure that best fits the requirements, then why not use that? Why use, say, an array? That would be overkill. And let's look at an array momentarily, because an array is probably the most simple data structure that you're used to or you've heard about. And you might think of an array, let's say it's an array of characters. A, B, C, D, E. And they're indexed. Now, with an array, you can have random access. I could get, for instance, whatever is indexed at 2 randomly, very fast. All I have to say is, what's in 2? Bam. We can immediately point to it and get the letter C. That's pretty good. But it's overkill if we know that we will only always look for the first element that is in a list or the last element that's in the list. Why do we need random access if we're always going to take whatever's first in the list or whatever's last in the list? And that brings us to stacks and queues. Stacks and queues are efficient data structures for adding and removing elements into a container when you know that you only want whatever was last put in the container, or maybe what was first put in the container. And we'll look at which one's which in a second. But the cool thing about this is that ahead of time we're thinking to ourselves, what is it we want to do, and what would be the best structure for us to do it in? In other words, do we want waffles, or do we want eggs, or do we want a lot of everything? And in this case, we want stacks and queues. So, continuing with the big picture idea, let's use an example. Let's say that we want to spell our name backwards. It sounds pretty simple. So let's say we have a container. My first name is Edward. And that container has one letter for each of my characters in my name. The last letter I typed, if this were me typing out my name, the last letter I typed was a D. If we want to reverse the name, if we want to go backwards, what's the first letter we would want? Think about that. What is the first letter that we would want to put? Would we need to randomly access, say, A? No, because A is in the middle of my name. It's not the first or last letter. And if we want to go backwards, we're going to use the last character, D. Now, once that's out of the way, what's the next character we're going to use? R, then A, then W, then D, and then E. We didn't need to randomly access any part of my name. We were able to just, one by one, go through the last letters that were put and make those letters first. Last in, first out. Last in, first out. And that is a stack. That exactly represents a stack. The last elements that are put in are the first elements that are taken out. How else might we think about a stack? Well, I mean, the easiest way, the obvious thing we could say is, let's say we have a table and we put books on them in the order we want to actually read those books. Well, if we were smart, we would put the book we want to read on top of the stack. We obviously wouldn't put it first, we put it last. And that book, the book we want to read, is the one that comes off first. Last in, first out. Again, very big picture, but this is a big picture of a stack. So let's move on to what the big picture is of a queue. And probably the easiest thing to think about is you're driving along the road and you want to stop at a restaurant, you want to stop at a store, and then you want to stop at a gas station. Now, if you used a stack, restaurant, store, gas station, remember last in, first out for a stack, then the first one the one on the top, the one next on the list, is the gas station. Well, if you're traveling along a road and this is the start, this is the stop, here's the restaurant, here's the gas station, oh, I'm sorry, here's the store, and here's the gas station. Well, if the gas station is the first one in the list, this isn't going to be a good trip, because first we're going to go to the gas station, then once that's off the list, the last one on the list would be the store, then we go to the restaurant, and then we're going to have to go all the way back to where we're actually trying to go. No, this is not what we want to try to do. What we want to do is go to the restaurant first, the store next, and then the gas station last. We want the first in the list to be the first out of the list. The first in is the first out. Once we're at the restaurant, then the next one that was in the list is the store, and the one after that is a gas station. Now we're following in a way that works out perfectly. Another example, and this one's something that you use probably often if you go to a library lab. Let's say there are 3 people that are trying to print out their reports. The first one is Joe here, then Sue, and then Anne. Who do you think should get their paper first? Some people might think they should get their own first. But in this case, let's say that everyone's trying to be fair and Joe isn't going to be a gentleman. What's going to be the order of things? We would most likely consider, since Joe hit the print button first, that Joe gets his paper first. Sue would get her paper next, and then Anne. First in, first out. Once Joe's out of the way, then Sue, then Anne. That is operationally, conceptually, a queue. So let's kind of ruminate on that for a moment. 2 new data structures, 2 new ways of storing and then retrieving data without an index. We don't need an index in these instances. We just need to know what came first and what came last. And those data structures are set up so that it's efficient to remove something and get either the first item that was put in the list or the last item that was put in the list. So now that we have this overview of the 2 structures, let's move on to the what. All right, so with the idea, with the concepts in our head, let's go back to the stack. Remember, the stack was last in, first out. The last item put into the container is the first one that's going to come out of the container. And what we're going to do right now is work through step by step, putting pizza, bread, and juice into a stack and then getting those back. Now, the requirement is that we do it in alphabetical order. So we first want bread, then we want juice, then we want pizza. We have our bread, we have our juice, and we have our pizza. When we add something to a container that's a stack data structure, we call that push. We push the item onto the stack. When we want to remove an item from the stack, and remember it's last in, first out, we call that pop. We pop it from the stack. So these are the two methods, the two transformations that will occur to the stack. Push and pop. Add and remove. So let's go through the bread, juice, pizza and add to the stack. We start off with an empty stack. Here's our first push. And what do we want to push into the empty stack? Remember, we want it to come out in alphabetical order. Because we want it to come out in alphabetical order, the bottom of the stack, the last one to come out of the container, is it going to need to be closer to Z or closer to A? Think about that for a second. What do you want to be at the top of the stack, the first thing to pop off? And what do you want to be, what do you want to be the last thing to pop off the stack? The pizza is the last thing you want to pop off the stack. So it's the first thing we need to put into the stack. And that's exactly what we'll do. We're going to put this pizza into the empty stack. And what we end up with is a stack with pizza at the bottom. Alright, now we have a stack with pizza at the bottom. Let's go ahead and build off of that. So now we have a stack with pizza at the bottom. Next is going to be juice. So we're going to build on top of pizza, and we're going to get juice. Okay? And the final one, I think you can kind of get an idea of what's going on here. Now we have a stack with pizza and juice. We're going to add in the last element. Last in, first out, so it'll be the first one popped off the stack. We bring that in and end up with pizza, juice, bread. So here's our container. We've successfully pushed items onto the stack. From there, we can move on to popping things off of the stack. So we have our stack here. It has pizza in it, has juice in it, and it has bread. We want to pop off the stack. What happens? Well, last in, first out. The last in was bread. Bread popped off the stack. That leaves us pizza and juice. I think it's pretty easy to get the idea of what happens next with this, because we keep going on the same pattern where we pop something off the stack and we get back whatever is next that was put on the list. Pizza, and then the last one we do, pop off the stack, we get the pizza, and we're back to our empty stack. Now to run through your mind for a moment, what do you think would happen if we brought the empty stack and we tried to pop off the empty stack? It's kind of a trick question because the answer is, who knows? That's not part of the basic idea of a stack. We can add things like question whether or not the stack is empty. And if it is empty, then we won't pop something off of it because, well, we don't know what happens if you try to pop something off of an empty stack. We could try to see if a stack is full. We could try to peek without popping. There are several things we could add to the basic idea of a stack, but ultimately this represents the procedure on pushing and popping, the basic idea behind a stack. The queue works very similar. Extremely similar, actually. So remember, the queue is first in, first out. Let's go back to that printer job we were talking about with Joe, Sue, and Ann. Remember, we wanted Joe to get his printout first because he was the first one to print, and then Sue, and then Ann. Well, let's say we went down the stack route. What would happen? So we have an empty container, and then we try to add Joe in there. So we push that in there. Remember, we're using the stack right here to see just what would happen. Well, just like we saw before, we get Joe, then we have Joe, and we're trying to add in Sue. And then finally, we're trying to add in Ann. Okay. What happens now when we try to pop off the stack? We have Joe here at the bottom, Sue, and then and. And gets popped off. What do I mean by that? I mean Anne gets her printer job done first. She was the last one to print, but she's the first one getting her printer job. Something's not right. You know, poor Joe and Sue, they're having to wait. What if someone else comes in after that? Then they're going to have to wait still. It could be forever before they get their printer jobs. So this won't work. Pop won't work. But if we just took the first in out first in, first out, then Joe would get the printer job done first. And then it would be Sue, and then it would be Anne. So really the only thing we have to change between stack and queue is how an item is removed from the container. Rather than removing the last item, we remove the first item. And in fact, I don't even have to redo this part right here. I just have to change the name. To in queue. You don't push onto a stack. I'm sorry, you don't push onto a queue. You in queue. Other than terminology, the action is the same. It's the removal that is different. It's what gets removed first that is different. And instead of popping, we dequeue. Dequeue gives us Joe and leaves us Sue and Anne. Now we have a happy Joe. Joe was actually able to get his printer job first because we used a queue instead of a stack. And the same thing with Sue getting the next opportunity for the print job to be done. We dequeue again, and we get Sue. So, Anne is still in the container. And finally, with just Anne left, we dequeue that, get Anne, and then get our empty container, our empty queue. These are very simple examples, but it's good to work through them so that you can get an appreciation for the process. Once you have the process down, it becomes second nature. You'll use this a lot in computer science, in programming. One thing I didn't go over right here, but it's the exact same process, and it's what I want you to think about in your assignment. That is, what happens if someone else or something else comes into the container before everything is emptied? So, with last in, first out, here we did all of the pushing and then we did all the popping. We did all the in-queuing and then we did all the dequeuing. But there's nothing to say that we can't push pizza and juice and then pop and then push bread. Think about what would happen. Last in, first out. If we had juice and pizza and then used pop, what is the last in that would be the first out. And then we pushed bread after that. Try to think about that. And the same thing with cues, first in, first out. What if after Joe got his printout, someone else, Stephen, decided to print out at the same time? Okay, so now Stephen's on the queue. But remember, a queue is first in, first out. So is Sue affected by Stephen now entering the queue? Who is first? Of course, Sue is first. You're going to see that the queue is really good in this case because you can keep adding to it, and the first person, or the first in line, is going to be the first one served. And probably one of the best examples of a queue is a queue. Literally queuing up for a line. You're going to a restaurant or you're going to a fast food place. Whoever's first in line gets served first, at least if everything's going well. So this is the what part. The next is the how part. And for the how part, we're actually going to switch back to the computer so that I can describe, so that I can type out an example of a queue.
Okay, this last part is actually the fun part as far as things go, because we're actually going to be looking at a brief example of how you would implement a stack and a queue in Python. Python's a relatively simple language, so even if you don't know Python, we can still go through it and see an example without being bogged down too much by the language itself. Now, we're using IPython in this example to go through it. The first thing we'll need to do, of course, is create a class called stack. This will be our implementation of stack. Well, there needs to be some container. I mentioned the word container a lot during the lecture, and in Python, the constructor, the first thing that gets called when you create an object from a class, is the init method. And this is just simply saying, hey, the first time you instantiate me, you make an instance of me, go ahead and go into this method. And since we want a stack, let's go ahead and create a variable in this class called stack. Of course, just like our diagrams, we're making an empty version of the stack. That's what we're starting off with. The two options that we have when we talk about a stack are the push method. So let's go ahead and deal with that. Now, the self keyword right there, all that says is, hey, I'm an instance. You know, I'm talking about the stack instance. Value is really what we want to pay attention to. Value in this case is the item that we're putting in. So in this case, we want to add to the stack that value. Now that plus equals is a convenient way of saying, hey, go ahead and add me to the end of this list, this container. Well, in this case, it's a list, but a container overall. So that says, go ahead, add me to the end. Finally, and this is where most of the work happens, we're going to pop off the stack. Well, with push, we were trying to get a value into the stack. With pop, we're trying to get a value off of the stack. So let's get a value from the stack. And Python offers this really cool option, -1. Basically says, hey, whatever's at the end of the list, go ahead and grab that. Now remember, with stack, it's last in, first out. Well, we're adding the last part to the end of the list. So that's why we're grabbing the last part of that list. Now that we have the value, we can actually do the popping itself, which is to get rid of that last value. Another cool feature with Python is this :-1. And what that says is, hey, get me everything from the beginning up until the last element. We want to not have the last element. Why don't we want the last element? Well, because we're popping that element off. And then finally, we want to actually return the value we just popped off the stack. So if everything is correct right here, we should be able to test our bread juice pizza example. Let's go ahead and create an instance of the stack. And let's go ahead and push first pizza, just like we did on the board in the example. Then we're going to push juice. Then we're going to push bread. And finally, we're going to pop those off the stack. We want to print those out. So let's go ahead and print stack.pop. So we're calling the pop method. Oh, I said break instead of bread. Pretend that says bread. Let's go ahead and pop the next one off, juice. And then finally, we get pizza. So that's a perfect example right there of a very simple stack. Let's do the same thing, but this time we're going to deal with queues. Now, just like with the stack, we're going to create a class. We're going to want to tell it, hey, we need an empty queue right at the beginning. Same way that we did with the stack. Then we're going to say, hey, when we enqueue, we're going to take a value and we're going to add that value to the end of the list. Notice there something really cool. Like I'd mentioned, the addition aspect is identical. There's no difference. Sure, we've changed the name of the variable from stack to queue, but it's the exact same expression. Now for dequeue, again, we do the exact same thing. We're removing something from the list, except this is the important difference. Notice that instead of using that -1 trick, I'm asking for the very first element in the list. The very first element in the list. Just like with the stack, I want to remove that element. I want to dequeue that element. So here we're going to use another cool feature of Python. It's kind of the opposite of what we requested right here. Here we said start with the very beginning and give me up to the very end. Don't include the very end. Here we're saying skip the first one and go all the way to the end. Again, because with a queue, it's first in, first out. And then finally, we return the value. So let's go ahead and test this example out with our printer situation. First, we're going to create the queue. Then we're going to enqueue Joe. We're going to enqueue Sue. We're going to enqueue Anne. Then we're going to dequeue, and there we have Joe. I didn't put print, so that's why it's a little bit different, but it's showing what comes out. So that's exactly what we expected. If we dequeue again, we get Sue, and if we dequeue again, we get Anne. So both of these are very simple examples of how we would actually implement a stack and a queue in Python. There's much more that we could accomplish, but for this mini lecture, we'll have to stop there. If anyone has any questions, please contact me. Thanks for your time.